This is rotational motion. Check your understanding. Question number 36 from the book Pathfinder. Let us see what is the question. Question is that there is a uniform sphere of radius r and mass m. You can see this is the sphere. It is rotating with an angular velocity omega naught I cap. So this is x direction. And free space, there is no gravity. A bullet of mass m moving in the positive z direction hits the sphere at a distance 0.2 r from the z axis. So perpendicular distance is 0.2 r and comes out almost in no time with a very small velocity without any loss of mass for the sphere. Okay, so mass of the sphere remains same before and after. As a result, the sphere starts rotating with an angular velocity same omega naught, right? This omega naught, but now about y-axis in such a way that point P, this is the point P, appears moving in positive z direction. Find the velocity of mass center of mass of the sphere after its interaction with the bullet, right? So first, let us draw the diagram of the data given. So this is initial condition. This is omega naught I cap. So if you use right hand rule, then from here, if you see, if suppose there is an observer here, then according to that observer, this should be, a sphere should be rotating counterclockwise. Then only the omega will be in this direction, right? Okay. So now after that, final, let us see this, let us ignore this for a moment. And finally, what happens? The sphere starts rotating along y-axis such that this point P, what is written, let us see, appears moving in positive z direction. So that means point P right now is coming out of the plane, right? So if it is coming out of the plane, that means velocity of this is perpendicular to this plane towards plus z direction. So again, if you think of an observer here, then the rotation should be counterclockwise. Then only right now point P will be, velocity of point P will be out of the plane. If it is opposite, then velocity of point P will be into the plane, right? So this much we have figured out. So this is in positive y direction. Now let us, and then one more thing is given, that the particle is moving and its distance is 0.2 r from z axis. So this is z axis, which is actually perpendicular, and then it is perpendicular, distance is 0.2 r. So the particle, the velocity of the particle might be in the any direction here, right? It is along that direction, but it might be coming at this point or this point or this point or this point, any point, right? So how I have decided that particle is coming here. So it is intersecting the sphere at this point in this coordinate, not in all these three quadrants. So let us understand, let's draw the diagram. So question is basically based on conservation of angular momentum because it is in free space. So there is no external torque acting. So if you take the system of sphere and this particle, then initial angular momentum is equal to final angular momentum. So let us draw the diagram and see. Initial angular momentum of the sphere is this I omega, right? Pure rotation, because omega is in this direction. And then final angular momentum, don't see this as of now, just we will arrive to this, right? The angular momentum of the bullet is in this direction from this conclusion. This is the argument. Initial is this, final is this. So the angular momentum of bullet must be in this direction so that it can cancel this component of the sphere, angular momentum. And then finally, this component is left. Okay, so that is what is going to happen. So if angular momentum of the bullet is in this direction, which is in negative x and y, so that means it is in this direction. Now you can comprehend that the velocity of the particle or particle will intersect the sphere in this quadrant only. Why? Because about origin, this will be r vector will be like this, and then velocity vector is linear momentum vector is out of the plane. So use right hand rule or left hand rule, any rule for cross product. You will see that then angular momentum will be in this direction. So one vector is this, another vector is in z direction. Take cross product of these two vectors, you will get that direction. Fine. So that is how we have decided that the sphere is this particle is coming in this quadrant. Okay, fine. After that is just the calculation part. We will write angular momentum conservation. So I have assumed that bullet passes through minus x naught y naught, right? That is what just now we have concluded. So angular momentum of the bullet is r cross p about origin. So I cross k, if you see, then you get this, right? Just write I cross k and j cross k properly without any mistake. So mv x naught plus mv y naught I cap. Now I'm going to conserve angular momentum about the origin. So initial angular momentum of the sphere is I omega 2 by 5 mr square, solid sphere. And for bullet, this is the angular momentum just now I've calculated. And final angular momentum of the sphere is 2 by 5 mr square omega j cap, because it is given in the question. Finally, sphere starts rotating about z axis, sorry, y axis, and there is no velocity of particle. Velocity of particle becomes zero. So final angular momentum of the particle is zero. Okay, so let us see what do we get from here. Two equations we'll get. So this is I cap and this is J cap. If we compare, then you get mv y naught is equal to this 2 by 5 mr square omega. Mv x naught is equal to 2 by 5 mr square omega. So that gives you that x naught is equal to y naught. Now, root over x naught square plus y naught square is how much? Root over x naught square plus y naught square is actually 0.2 r. That is given the distance from z axis. If both are equal, then you can very easily conclude that x naught, y naught both are 0.2 r by root 2, correct? So this, then now you can take any equation like this equation and then find out velocity of the particle. So if this is the velocity of the particle, what do you have to find out? You have to find out velocity of center of mass of the sphere. So for that, I'm going to use consideration of linear momentum. So linear momentum of initial linear momentum of the sphere was zero. This is the linear momentum of the particle mv k cap. It is moving along, it was moving along positive z direction. And finally, linear momentum of the sphere is mv1. Linear momentum of the body is m times vcm. So this formula I'm using for a sphere, mass is m. And let us say this is the v1 velocity. This we have to find out. Both will be in k cap direction only. So this V we have already calculated. So if you substitute this V, then you are going to get V1 as 2 root 2 R omega. So this is the final answer. This is the velocity of center of mass of the sphere. So that is the analysis. Thank you very much for watching. If you have liked this video, like this analysis, please hit a like button and please subscribe to this channel also. Thanks a lot.